What do you think will happen if I let go of this balloon without tying it? Let's find out. The balloon moved because the air inside was under higher pressure. When the opening was released, the pressurized air rushed out in one direction, pushing the balloon in the opposite direction. The same principle powers many industrial machines. Pneumatic cylinders, air tools, and control valves all rely on compressed air. But how does ordinary atmospheric air become a reliable source of industrial power?
Before we discuss the compressed air, we need to familiarize ourselves on these parameters: pressure, flow, temperature, and volume. Pressure describes how strongly the air pushes. Flow refers to the amount of air moving through the system over time. Volume is the amount of space occupied by the air, while temperature indicates how hot or cold the air is. These four parameters are closely related, and changing one often affects the others.
The journey begins when atmospheric air enters an intake filter, where dust and large contaminants are removed. The air then enters the compressor, where it is squeezed into a smaller space. As the volume decreases, the pressure increases, storing energy in the compressed air. Because compression generates heat, the air passes through an aftercooler to reduce its temperature. When air is cooled, it lessens its ability to hold water vapor, and it turns water vapor into liquid, undergoing the condensation phase. An air receiver stores compressed air, stabilizes pressure, and allows condensed water to collect before draining. The compressed air then passes through a dryer and filters that remove moisture, particles, oil, and other contaminants. Finally, clean compressed air travels through the piping network to cylinders, valves, air tools, and production equipment where useful work is performed. Compressed air isn't automatically clean. It may contain particles, water, and oil. These contaminants can cause corrosion, equipment damage, product defects, pressure loss, and costly downtime. That's why industries use ISO 85731 to classify compressed air quality based on particles, water, and oil.
Not every application requires the same level of air quality. A workshop, a food processing facility, and a pharmaceutical plant all have different air quality requirements. The goal is simple: do not under-design and do not over-design. Always match the air quality to the specific application. To verify compliance, technicians regularly test compressed air for particles, moisture, and oil contamination. The measured results are then compared with the required ISO class, and any non-compliance is corrected to maintain reliable system performance.
From intake and compression to cooling, storage, treatment, and distribution, every stage plays an important role in delivering reliable compressed air. The next time you hear a compressor running, remember, it isn't just producing compressed air, it's powering an entire industrial process. Thank you for watching. I'm Grant, and remember, at Gruntech, we only deliver smart utility solutions for your industry. Did you know more than 2,700 years ago?
The ancient Assyrians had a clever underwater secret. They carried air-filled animal skins, using them as a primitive breathing device beneath the water.
While the air wasn't mechanically compressed like today's industrial systems, it demonstrates one of humanity's earliest uses of stored gas to perform useful work.